beta hat 1, and it's two parts to this, is sigma xy minus n times x bar y bar divided by sigma x squared minus n times x bar squared, and the estimated intercept beta hat 0 y bar minus beta hat 1 times x bar. Alright, so that we can understand how these formulas work, let's do this on an example. Let's use this example, and I'm going to write this data on our page, and we'll work it out from there. Alright, and here we have the data transcribed to the page. Alright, to get all the things we want, like sigma xy and x bar and y bar and sigma x squared, we'll need two more columns here, one for x squared and one for xy. In the x squared column, we'll want each of the x's and squared, just like we did in 214 when we were calculating variances. So minus 2 squared is 4, minus 1 squared is 1, 0 squared 0, 1 squared is 1, 2 squared is 4, and we're going to add these up later, but for now let's complete the last column, x times y. So again, similar sort of thing, but now x times y for each row. So minus 2 times 0 is 0, minus 1 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1, and 2 times 3 is 6. Alright, let's now add these up. We add up the x's, find that's equal to 0, we'll call this sigma x. Add the y's, that's 5, sigma y. Add the x squareds, that's 10, sigma x squared, and the xy's 7, and that's called sigma xy. Alright, so now we can go ahead and do our calculations. First we'll start off with n, and it's not really a calculation, it's the number of data points. There are 5 data points. X bar, the average x, as in 214, sigma x on n. Sigma x is 0 divided by n of 5, so we get a 0. Y bar, the average y, sigma y divided by n. Sigma y is 5 divided by n of 5, and that's 1. Alright, and then we're finally ready to do our beta hat 1. Alright, let's write out the formula again. Sigma x y minus n times x bar y bar times, divided by sigma x squared minus n times x bar squared. Alright, sigma xy from the table is 7 minus n is 5 times x bar 0 from over here times y bar 1. It hardly matters. This 5 times 0 times 1 is 0, divided by sigma x squared. Sigma x squared is 10 minus n, 5 times x bar 0 squared. Right, and in this particular case, since we have x bar of 0, these terms go away. And so we're left with 7 divided by 10, and the result is 0.7. Alright, then we can do beta hat 0. It's y bar minus beta hat 1 times x bar. Y bar is 1 minus beta hat 1 0.7 times x bar of 0. And again, since x bar is 0, this last term goes away, and beta hat 0 is equal to 1. Therefore our equation which in general will be y hat is equal to beta hat 0 plus beta hat 1 times x. In our particular case will be y hat is equal to beta hat 0 is 1 plus beta hat 1 of 0.7 times x. Alright, and this is the estimated line or relationship or regression. So in any problem that asks for you to estimate the regression or line or relationship, this is as far as you need to go. Sometimes there's a tendency for some students to do too much of this work. Alright, so our estimated regression is over here. Let's now do another part to this problem, that is to plot what's called the scatter diagram. As Excel and other spreadsheets will call it, the XY plot. This is not the typical type of diagram. And after that, on top of that, we're going to draw in the regression, or regression line, if you like. Alright, so here we have our axes, x and y. We, in this case, need some negative values on the x. It's not a very common situation, but here we need it. Alright, so we have our points. Minus 2 for x and 0 for y. Alright, let's put those in some other color. Alright, so minus 2 for x and 0 for y will be there. Minus 1 and 0 will be here. Next point, 0 for x and 1 for y. Here. 1 and 1. X is 1, y is 1. And then finally 2 and 3. Alright, so this so far is our scatter diagram. Next we want to draw in the regression line. Alright, to draw the regression line we need 2 points. There are 2 points that are always on the line, but they're not always useful to draw them. The first point is the intercept, where x is equal to 0 and y is beta hat 0. Beta hat 0 in our example was 1, and let's change the color on that. Alright, and that's already where we have a point, so that is over here. Okay, so this is the point 0, 1, the intercept. The other point that's always on the line, and not always obvious at first, but that's the average point, where x is x bar and y is y bar. And in our particular case, if you look back at the numbers, that's also 0 and 1. But we need 2 different points. In this example, only in this example where x bar is equal to 0, are they the same point. So instead of 2 points, we still only have 1 point. So we need another point. So to do that, we'll let x equal some value. Alright, so we have x is going from minus 2 to plus 2. Let's just make our life simple and let's x equal 2, and let's work out the value for y. So y hat will then be 1 plus 0.7 times x, and that works out to 2.4. So another point that's on the line, so x is 2 and y is 2.4, and that will be roughly here. Alright, and then we can draw in our equation. Alright, and here we have it. We draw a line, which is green, through our 2 points, the intercept, alright, where x is 0 and y is beta hat 0, which is 1, and the second point that we worked out where x is 2 and y is 2.4. Alright, so this then is our equation. Let's just write down the value of the estimated line. Y is equal to 1 plus 0.7 times x, and that's our equation. Alright, so we've done two things here: estimated the straight line, estimated the regression, and then the second thing, we plotted the scatter diagram, the XY plot, and drew in the regression.